Welcome to section 8.3. This section is divided into two parts, so there's going to be a video for part 1 and a video for part 2. So this is 8.3 part 1. We're going to start, you should have a copy of this posted in Schoology, so you should print this off and keep it in your notes. We're going to start by defining the unit circle. The unit circle is a circle in the coordinate plane. Its center is at the origin, and it has a radius of 1. Okay, so here's a picture of the unit circle that I've drawn. Okay, so you can see that it's just a circle in the XY coordinate plane. The center is at the origin, and then the radius is 1. So because the radius is 1, we can label points on the circle. We have the point at order pair 1, 0. 0, 1, negative 1, 0, and 0, negative 1. The equation of the unit circle is x squared plus y squared equal 1. And then as the point xy here starts at the order pair 1, 0, and it moves counterclockwise in this direction along the circle, the angle theta here will move from 0 degrees all the way around to 360 degrees. Okay, so as this opens up wider and wider as it goes around, then this angle is going to go from 0 to 360. Okay, and then this is the Greek letter theta that we're using to represent our angle. So that's what the unit circle is. It's just a circle with radius 1 centered at the origin. All right, and then we'll go to the next page. So on page 425 of your textbook, they ask an essential question: how can you use the unit circle to define the trigonometric functions of any angle? So we already talked about how we can define the trig functions for a 90-degree angle. You'll recall the SOHCAHTOA, sine is opposite over hypotenuse, all of those rules that we discussed before. How can we use that for any circle? So, or excuse me, for any trig for any angle rather. So to help us make sense of this, I drew my unit circle again. My radius is going to be 1, and then I've got coordinates for whatever this x and y value are. If I remember that my radius of my circle is 1, it's centered at the origin, so we can draw a triangle in this inside here so that you've got radius 1, which is going to correspond to your hypotenuse, and then you can create a 90-degree angle down here where this point comes down and meets the x-axis. So the x value in this point is going to correspond to the length from the origin to here, so that's going to be x, and then the height of the triangle from the x-axis up to the coordinate is going to be the y value. So if this is an ordered pair 2, 3, then that means the x value is 2 and the y value is 3. And the radius again is going to be 1 if it's a unit circle. So with that information, we're going to find all 6 trig functions. So to find sine of theta, rather than we're going to use opposite over hypotenuse. All right, well, opposite from theta would be y. So we're just going to say it's y. And then the hypotenuse is going to be r. So sine theta equals y over r. So these definitions can be used for any triangle. Cosine theta, remember that one was adjacent over hypotenuse for a right triangle. So if we come up here, adjacent to angle theta is side x, and then my hypotenuse is going to be my radius r. So I'm going to say cosine theta equals x over r. Tan theta was opposite over adjacent. So in this case, that would be y over x. And again, the remaining 3 trig functions are the reciprocals of the original. So cosecant is the reciprocal of sine. So cosecant theta is going to be r over y. Secant is the reciprocal of cosine. So that's going to be r over x. And cotangent was the reciprocal of tangent, so cotangent theta we can say is x over y. Okay, Now, these three here, you're going to need to memorize. To me, I just use the little silly mnemonic device. I say S-Y-R, so I just make up the little phrase sir. Cosine, I don't really have a good one for, but for tangent, you can do T-Y-X. I think ticks to help you. That's the way I remember mine. So whatever works for you. But you need to have these memorized so that you can find sine, cosine, and tangent for any triangle. And then just know that these over here will be the reciprocals. Okay? And we are ready to do some examples now. Okay, so if you did not, I will photocopy these and post these in Schoology so you'll have access to this just like I've done it. Okay, so I'm in the note-taking with vocabulary. I have basically explained the first page of this. So they say in your own words, write the meaning of each vocabulary term. So for unit circle, you could just say that that's a center with radius 1, centered at, it's a circle with a radius 1, centered at the origin. Quadrantal angle, excuse me. I did not describe what that means. I'm just going to draw a picture for you. So a quadrantal angle, let's say we've got a circle like this. We've got the x and the y-axis. So quadrantal means that it's going to be a 90-degree angle. So let's say theta moves 90 degrees. So it would be 90 degrees. And then the next one would be, if it gets over here and comes to, basically it's going to land on the x or the y-axis. So the terminal side of your angle will be on the x or the y-axis. So we were talking about a quadrantal angle. A quadrantal angle is an angle in standard position. So remember, standard position just means that it starts on the x-axis and its terminal side lies on an axis. So a quadrantal angle is either going to be a 90-degree angle, or it's going to be a 180-degree angle, or it can be this situation where you've got, that would be 270 degrees, or it could be, let's say you start here and you go 90, 180, 270, and you come all the way back and create 360 degrees. Okay, so that's a quadrantal angle. You see that it means that its terminal side lies on either the x or the y axis, and it's either going to be 90 degrees, 180 degrees, 270 degrees, or 360 degrees. Okay. And then reference angle. I'm going to hold off on reference angle because that's going to be in the second video. Okay, so let's go on to the second page of my notes. Well, we talked about the essential question for. So we are now ready to look at some examples. So I'm going to the extra practice. 8.3 extra practice, and in the first video we're just going to focus on numbers 1 through 4. In number 1, in exercises 1 and 2, evaluate the 6 trigonometric functions of theta. Okay, so to do these, we need to use the definitions that we just found. These, so we said the sir and the ticks. I'm going to use that to help me out with these. Okay, so for number 1, I need to evaluate the 6 trigonometric functions of theta, and my point that I'm given is ordered pair 2, 6. So that means x is 2, y is 6, and I have to find my radius r. Okay, well, to figure out the radius, if you recall, so we know that from the Pythagorean theorem, x squared plus y squared equals r squared. And if we look at the triangle that we're working from, okay, you can see, if you look at this, that's x, that's y, and that's our radius, okay? So now this point that I'm given is not necessarily on the unit circle. So to find the radius, that's like finding the hypotenuse. So in order to figure out r, we need to we can first solve this for r. So rather than doing the x squared plus y squared equal r squared, we can write it as r equals the square root of x squared plus y squared. And we'll use this variation of the same thing. So to find r, I need to do r equals the square root of 2 squared plus 6 squared. So that's the square root of 4 plus 36, which is the square root of 40. And to make life a little easier on myself, I'm going to go ahead and simplify my radical now. The square root of 40 can be simplified because if I take 40 and break it down, that's 2 times 20. 20 is 2 times 10. 10 is 2 times 5. Because I've got a pair of 2's that show up in the factor tree, that means I can take a 2 out of the square root. So the square root of 40 can be written as the square root of, this 2 can come out, and then the 2 and the 5 stay inside, so 2 square root 10. So I'm going to, instead of writing square root of 40, I'm going to write 2 square root 10 for r. And now we're ready to find everything that we need. So for sine theta, I know that sine is y over r, so it's going to be 6 over 2 square root 10. And I have to rationalize my denominator because I don't want to have that radical in the denominator, so square root 10 over square root 10. And that gives me 6 times the square root of 10 over 2 times 10, which is 6 square root 10 over 20. And that can be simplified as, let's see, 2 goes into both of those, so 3 square root 10 over 10. So on my sheet, for the very first question, I can write sine theta equals 3 square root 10 over 10. And then I'm ready to find cosine theta. Alright, so for cosine, so for cosine theta, that one is x. That one's defined as x over r. So that means in this situation, x is 2, r is 2 square root 10. I can simplify that to be 1 over square root 10, but I still have to rationalize my denominator, so multiply square root 10 over square root 10, and that's going to give me square root 10 over 10. So cosine theta is square root 10 over 10, and I'm going to put that over here. And then I find tan theta. Tan theta is defined to be y over x. I remember ticks to help me. So to find that one, y was 6. So y was 6, x is 2. So that's going to be 6 over 2, or 3. So tan theta in this example is 3. And now I'm ready to find the remaining 3 trig functions. Cosecant is the reciprocal of sine, so that's going to be 10 over 3 square root 10. I need to rationalize my denominator, so multiply square root 10 over square root 10. That gives me 10 square root 10 over 3 times 10, and that gives me square root 10 over 3. So cosecant theta is square root 10 over 3. Okay, next one is secant. Secant theta, that one comes from the reciprocal of cosine, and we found cosine to be square root 10 over 10. So that means secant is going to be 10 over square root 10. Multiply square root 10 top and the bottom to rationalize, and you get 10 square root 10 over 10, or just square root 10. So secant theta is square root 10. And finally, cotangent theta is easy. Cotangent is the reciprocal of tangent, and we found tan theta to be 3, so cotangent is 1/3. Okay, so that's number 1. All right, and we can look at number 2. So for number 2, we have x, and this one is -4, y is -3, and we need to find r using the formula y equal the square root of x squared plus y squared. So we'll do r equals the square root. I'm going to use parentheses when I put in my -4 and -3, square, -3 quantity square. So r equals the square root of, that's going to be positive 16 plus 9, or 25. So r equals square root 25, so r is equal to 5. So then now I have what I need to find all 6 trig functions. Okay, so I'm going to come down here. I'm going to start sine theta is y over r, so that's going to be -3 over 5. Cosine theta is x over r, so -4 over 5. Tan theta is y over x, -3 over -4, or positive 3/4. Cosecant theta, reciprocal of sine, so that's going to be -5/3. Secant theta, that's the reciprocal of cosine, so -5/4. Cotangent theta is the reciprocal of tangent, so that's going to be 4 over 3. And that's it. So I'm going to put it over here, sine theta. I'm just going to list them on my sheet. It's -3/5. Cosine theta was -4/5. Tan theta was 3/4. And then cosecant was -5/3. Secant was -5/4. Cotangent is 4/3. Okay, and again, I will scan this and have it available for you as a resource. Alright, so that was my work for that. Number 3. In numbers 3 and 4, we're asked to use the unit circle to evaluate the 6 trigonometric functions of theta. Now, they don't mention this in the problem, but these are quadrantal angles. With quadrantal angles, the unit circle is really easy to use because it's either going to be, if you think about your unit circle, alright, it's either going to be 0, let's draw a circle in here. So, x, y. If this is the unit circle, my angles here would be 0 degrees, or also 360 degrees, and it would be 0 radian. And then when you come up here, you're going to have 90 degrees, which is also pi over 2 radian. And then the next one is going to be over here at 180 degrees, and that is pi radian. And then down here is 270 degrees, and that would be 3 pi over 2 radian. And then if you come back up here, you're 360 degrees, or 2 pi radian. Okay, so they're either going to be one of these values or a multiple of one of these values. So for number 3, -90 degrees. Alright, so they want us to find all 6 trig functions of -90 degrees. Okay, so remember, if it's a negative degree, you're going to go counterclockwise. So for number 3, I need to go back. So my angle theta would be like this. That's -90 degrees. So that puts me here. So I need to find sine, cosine, tangent, etc. of basically 270 degrees. Okay, so I can write sine theta Once you can see where you are on the unit circle, it's not difficult to find these values. Again, what are the coordinates? So remember, if we're starting here with this being the unit circle, the radius is 1. So that puts, we have an ordered pair right here of 1, 0. We have an ordered pair here of 0, 1, because that just means the radius is 1. Okay, back here you've got an ordered pair of -1, 0, and down here you've got an ordered pair of 0, -1. So that you've got everything you need. So sine we know is y over r. So y here is -1, and the radius is 1, so it's just -1. And by the way, if you're on the unit circle, sine is just the y value because you're dividing by 1 for your radius. So when you're using the unit circle, for any of these ordered pairs that you see, sine is always the y coordinate and cosine is always the x coordinate. So for cosine theta, still at the same spot, it's going to be the x value, 0, because that's going to be x over r, and r is 1. Tan theta is y over x. Okay, so y over x in this instance would be -1 over 0, and because 0 is in the denominator, that means it's undefined, because we can't divide by 0. Okay, so we've got these, and then we can find the remaining ones. So cosecant theta is going to be the reciprocal of sine, so that's also -1. Secant theta is the reciprocal of 0 over 1. So if we flip that, we're going to get 1 over 0, but that's undefined. And finally, for cotangent, we need the reciprocal of -1 over 0, so that would be 0 over -1, which is 0. So my answers for number 3, I had sine theta is -1, cosine theta was 0, tan theta is undefined. And then I had cosecant theta was -1, secant was undefined, cotangent was 0. And then let's look at number 4. So in number 4 we have theta equals 4 pi. Okay, so where's 4 pi? I'll try to draw my circle as neatly as I can. I'm not very good at it, but here's my circle. Okay. So we're starting here at 0. One full rotation is 2 pi. Another full rotation is 4 pi. So we are looking at this point right here for our angle theta. This is our angle theta right here. And it is the coordinates, because this is the unit circle, is my radius was 1, so that makes my ordered pair 1, 0. And I don't think I need any more than that for this problem. As long as we understand that 4 pi is 2 full rotations right back to where we started from here at ordered pair 1, 0. So we can find sine theta. Let's see, I'm going to put this straight on my paper, I think. I think this is pretty straightforward. So for sine theta, okay, here we go. Sine theta is going to be my y coordinate at this point, so it's 0. Cosine theta is my x coordinate, which is 1. Tan theta is y divided by x, so 0 divided by 1, and that's 0. cosecant theta is the reciprocal of 0 over 1. So sine was 0 over 1, cosecant is 1 over 0, and that is undefined because 0 is in the denominator. Secant theta, the reciprocal of 1 is also 1. And then cotangent of theta, okay, so remember tangent came from y over x, 0 over 1. If I take the reciprocal of 0 over 1, I get 1 over 0. And that is undefined because I'm dividing by 0. Okay, so that is it for those examples. So your assignment is going to be page 430, and this is 8.3 part 1. Page 430, problems 3 through 14 all. Okay, so just see me about checking even answers with my textbook, and this is what you need to do for the first part of section 8.3, page 430, 3 through 14 all.